Hello everyone, this is Alex Designman, and in this video we are going to continue with the automotive drawing project that we did in the last video. So I made a little change of plans with this video series about the drawing, because I noticed that it's going to take a long time to put this whole harness on a drawing, and the video can be very long. I decided to make only a smaller part of this harness, and to compensate for that I did something else. So this is where we were in the last video. We did this small part of drawing. Well, I started to add here connectors, and I also showed in CATIA V5 drafting workbench how you can use this command where we instantiate symbols that after that we can use in the drawing. So I just got in touch with some friends that I have that work in various automotive companies around the world. And they told me that in fact CATIA V6 flattening workbench works way better than CATIA V5 flattening. So there are companies that use the flattening workbench to create those kind of drawings that they will be sent to the manufacturing plant, and after that manufacturing plant uses other softwares like capital XC or capital H to create the drawing that is going to be printed and installed onto the drawing board. And this is the drawing that they use for the drawing board. So this one here has some colors, others might be black and white. So I already did one video where I show how to create those drawings with CATIA V5 flattening workbench and with drafting workbench here. In this video and in the last video I'm showing how to manually create those drawings here, and how you can also manually create them with Excel or PowerPoint. So I'm going to show that in one specific video. We're going to work faster. And to compensate for all of those, I received an original drawing from an automotive company, a very big automotive company in the world. So the drawing is going to be partially covered. So I'm going to only uncover this with a zoom out like this to see how it looks. So this is the whole drawing that they are going to print and add onto the manufacturing board. There are a lot of details here, so there's everything here, all the details that need to be added. In here in this table there are all the circuits. There are also all the circuits details also on those smaller tables around here. And on this other table here there is also the complexity or variance or whatever you want to call it, depending on various companies. They have different names for this. Some other companies they use the name composite CAD for complexity or for variance. So the harness operator has all the details to build the harness on this drawing, from circuits to materials to everything. And the one thing that they did here, and I want to update on our drawing, is that they added all the sections for the clips, for the retainers here, and they just added the section symbol only where you have a retainer. So we are going to do the same thing on this drawing. And now I'm going to zoom in here on this area where there is a lot of stuff covered up, and we are going to take a look on how is this drawing being made. Here we have the section for each clip, exactly like we did in the drawing. We have a section of the clip taken from CATIA V5 and a circle with a hash that represents the bundle, and here we have something that represents the table. So this shows the operator how is the clip going to be positioned on the harness according to the working table. So this needs to be done for each clip, and the way they identify those, it's at the section, so it's a normal standard for sections. You have like 2 letters, so TM1, TM1, and they started from A, and you get to many letters if you have a lot of sections. So in any mechanical drawing we will see this happening. And here we have connector, again, VO taken from CATIA V5. This represents the bundle, those lines. There are a lot of markings around here that indicate the tape that needs to be added. So the way this is done, this is the connector. In here you must have the connector ID, the connector part number also. So an ID, it's unique to that specific model year. So those IDs You can have an ID from a connector from 2013, from a vehicle that has been produced in 2013, so it has to be unique. Then we have some codes around here that represent the tape. So there are a few kind of tapes that can be added on drawings. So I discuss about those kind of tapes in my courses on Udemy. So there is tape that it's resistant to abrasion. There is tape that is resistant to water, ingress, and debris. There is normal tape that is the cheapest one, that it just holds the wires together. There is something that we used to call fluffy tape that has it's a thicker tape that it's anti-vibration and noise. So there are many kind of tapes. You can have corrugated tube, you can have a lot of protections that need to be indicated here. And those points, they either indicate a measuring point or a splice. So sometimes a splice needs to be added somewhere, or if not, you have a junction or a measuring point, which is, for example, this is a measuring point on this clip. So to avoid to make this video too long, I'm going to do a lot of silent work so I can fast forward. So this way you can sit back, relaxed, and watch what I do here. And from time to time I will try to explain some of the things. So one thing that we are going to do, inspired from the manufacturing drawing, is that we need to show the face of the connector only. We don't need to show any other side of each connector, so I'm going to delete this symbol. And also for each clip I need to add the measuring point. So for example here, I can add this as a small circle here. So it has to be visible when I zoom out. So this is a measuring point. Let's see on the sheet how it looks. And we also need to move so that the measuring point is right on the line that we use for the bundle. Let's also do this clip. I'm going to paste the same dot. I'm going to move it. So I'm just going to add it here to have it visible on the drawing. So one trick here is to use the same symbols when you add a clip on the bundle, but have different kind of symbols when you need to show different sides of this clip for the section. So this plastic channel here, that we have it here, this one can be saved as a symbol. It has to be a very simple symbol, and you can also add projection separately showing how it really looks in CAD. But we also need to add the measuring points for this one. So we have one here, one here, and one here. And then we have those branches. So I'm going to move this. Here we have those clips. This one. And those ones we need to move them. Like this. And this side here, I'm just going to delete this branch. So now let's make the symbols for those connectors. In here on the symbol, we can add already the part number of this connector because it's going to be unique. And we also need to add where is pin 1 for this kind of connector. So maybe it needs to be added with colors like this, or maybe a balloon like this one. So we have pin 1 here. So you have pin 1 here, pin 20 here. This means that you're counting from here to here. So you have 2, 3, 4, 5, 6, all the pins everywhere. If we have pin 20 here, it means that we're counting and then starting from here. And this fact has to be checked on the datasheet for a connector. And all the informations that are unique for this connector part number can be added on this symbol here. And here it can be saved under the name of the exact part number of this connector. I'm going to write here just C1, style sheet component. Here we can have instead of C1, in fact, we can have the part number of the connector because you know from CAD what's the part number. In CAD, you're going to have the part number in the name of the connector. So when you look here, okay, so I need to add that part number on the drawing. This is not going to be any confusion here with all the information. And we also need a symbol for every type of junction point or measuring point that we are going to use. So let's also do one of those. And we can have a different kind of point for a junction. So it's also something to measure, but it's also a junction point. Stage sheet component, measuring point, we add it here. And stage sheet component, junction point, let's add it here. So this is a junction. This is another one. And we have measuring points everywhere. We don't add one here This is just a corner, you know, it's like a bundle. We don't add one if we don't need one, and if I'm going to add a measurement here, it's going to be considered from this point to this point. This is what the measuring points are for. And also we need to create a symbol, a different symbol for every letter that we are going to use. So let's say that we are going to use, and in the name we can have something like this. So then I can just copy it inside the sheet, change the name, let's say to AB. So I just copied this and I'm changing here the letters, so it's not that hard to do it. So those libraries of symbols are created while drawing, so you don't create them all, you just create one when you need it. So it's going to, some drawings are going to take longer to do because you need to make a lot of symbols, but they need to be done. So in each company that you're going to go, they probably already going to have those symbols. And another thing that we need to add here is going to be connector ID. So this might have different names in different companies. Some companies, they call it reference number, connector ID. So this is a number, a code that can be inserted in any software and you're going to find it. You're also going to have to insert those in CATIA as an instance name. And here we need measure point here, measure point here. And we need to insert the symbols for both of those connectors that we have. So I'm going to do those really quick. So those are the other two symbols. Just going to delete them from here. Here we have the branches. So you can see when you do all the work how easy it can become to do all of those. So you can use this combined with CATIA V5 or V6 flattening workbench, because it's going to be easier to make some symbols that you have to add on top of the flattened harness. And then one of the last thing that has to be done is to add all the numbers that represent the measurements between the measuring points. And this, of course, they have to be taken from CAD, from clip to clip, from clip to connector, from clip to clip again. So everywhere we need to add the measurements and also add codes for the tapes. So you might have something like T120, so this might be the normal tape that you add from here to here. And if you have the same tape from here to here, you need to multiply this everywhere. So of course you can have those codes as symbols saved, where you can just instantiate and add them. So you can see here that the same tape is added between the measuring points. So even if the same tape, they write it everywhere, because the operator needs to know when it's going to stop with that tape. And this is how you essentially going to create a drawing from scratch. This happens pretty rarely, that you're going to have to make a drawings from scratch. But when you go, let's say that this is a model year 2020, is this vehicle. So when you make the next model year 2021, so let's say this is a vehicle 2024, so it's the project is closed. So let's say this is a vehicle from 2023. Let's say the project has been closed in 2023, and this vehicle is being produced on the assembly line in mass production and is being sold to the client. So in this case, everything is frozen, nothing can be modified. And in 2024, you make a new model year for this vehicle, and there are modifications on this main cabin harness. So let's say that this device is different and now has 3 connectors instead of 4. Let's say that this device has been modified only on the inside, so you need one of the connectors needs to be replaced with a smaller one. Some studs have been moved around here, so you have now different dimensions between those clips. So let's say you have some modifications to do on the 3D harness, which you are basically going to copy paste the harness from last year, and you are going to make those modifications. You are going to call it 2024 instead of 2023. It's a new copy on the hard drives. And after you make a modification, you basically copy paste the entire drawing that has been made years ago maybe, and you just do those small modifications on the new drawing. So you don't make a new drawing every year. You just copy paste from the previous year all the time. And you need to send those modifications to the manufacturing plant. And many times you don't even create a new copy of your drawing. You just take this drawing that they have and you modify here by using screenshots, PowerPoint, maybe Excel. And this is called like a modification. This is not a drawing anymore. This is, some companies, they call it an engineering change request or a change or a modification, and they usually have a number. There is a system for those modifications, and they have to attach circuit files to those things on this certain software that gestionates them, that manages those numbers. And you also need to add a PDF with your modifications to this drawing, and each department is going to connect to this engineering change request it's usually done by the responsible for the harness, which is the EDS engineer. So this might be you. And then everybody goes into that engineering change request onto that software, onto that number, and they attach everything from circuit team to complexity team to EDS team, and even cost department teams. They are going to attach how much money has to be spent for that specific modification. So now this video it's long enough, and in the next video, probably is going to be the end of the series, the next video or maybe 2 videos, I'm going to show how we make those modifications with PowerPoint and Excel, and also I'm going to show some quick examples on how you can make the exact type of drawing, but this time using PowerPoint or Microsoft Excel. So there are a lot of companies that use those because they are already paying for PowerPoint of Microsoft Excel for everyone in the company, and they are not going to invest more money into a license for a software that creates drawings, and that drawing needs to be created every few years or something like that. So that's a software that is not going to be used a lot. And they usually, that's why they don't invest, and they just use whatever they have in the computer to create a few lines and some symbols and so on. So until then, I recommend to play around with everything I showed in the CATIA V5 drafting workbench. If you want to learn the full drafting workbench, I teach that in my CATIA V5 course on Udemy. So I hope you enjoyed this, and see you in the next video.